What's going on, 8th grade? This is Mr. Bradford. Some of you may remember me from the last Monday we were in school. Most of you weren't there, though. We're going to be fumbling through this together. Before I start, here's my email right here, zach.bradford@cedarvilleschools.org. If you have any questions, just go ahead and email me. I'll be checking my email multiple times a day, so don't hesitate. Hopefully I can help you out. Last you guys left off, you and Miss Morton were on Earth, Sun, and Moon, so we're going to do a little something over primarily the Sun and Earth. Maybe the Moon will be the next part. I'm kind of feeling a way through this just like you guys. I uploaded something to Miss Morton's Google Classroom, so you guys should have an assignment in there. Earth, Sun, and Moon. Looks a little bit something like this. We're only doing through 10. So hopefully I cover everything that you guys need to know to answer those 10 questions right there. So we're talking about the Earth and the Sun. So we got day and night, obviously. The Earth rotates, right, on its axis as it revolves around the Sun. It takes approximately 24 hours a day for a complete rotation to occur. This counterclockwise motion occurs from west to east, causing the sun to appear to rise in the east and set in the west. We all know that it takes 365 and 1/4 days a year, right, leap day, for the Earth to orbit, right, the sun. This is called an elliptical orbit. Also, I meant to say this earlier, I'm going to proceed based on the assumption that you guys can pause and buffer at any time, so I'm just going to kind of go on through it. So we got our 24-hour rotation, then we got our 365 and 1/4 day orbit around the sun. I got this video here. It might be a little bit basic for some of you, but I think it covers a lot of the information that you guys are going to need to go over that assignment. So we're going to go ahead and press play here.
You've seen the sunset, right? And if you get up early enough, maybe you've seen it rise too. But have you ever wondered, if the sun rises every day and sets every night, where does it go when we can't see it? Well, nowhere. It's actually us that goes somewhere, because we're on the Earth and our planet is always turning or spinning on its axis. Imagine a line passing through the center of the Earth that goes both through the North Pole and the South Pole. We call that invisible line the axis. Earth spins around on this axis like a top. This spinning movement is called the Earth's rotation, and the Earth's rotation is what gives us day and night, every day, all year. If you're on the side of the Earth that's facing away from the sun as the Earth is spinning, it's night. If you're on the side facing the sun, it's, you guessed it, day. Now hold on tight, because the Earth is actually moving in more ways than one. At the same time that the Earth spins on its axis, it also orbits or revolves around the sun. This movement is called its revolution. One full orbit all the way around the sun is one revolution, and the Earth takes 365 days, or 1 year, to complete a revolution. So have you got all of this so far? The Earth is rotating on its axis, creating day and night, and at the same time, it's revolving all the way around the sun. Now here's the thing. As the Earth is both rotating and revolving, it's not sitting straight up and down. Its axis is actually tilted, just a little. It's not all that much, but this tilt causes one part of the Earth to lean towards the sun, while another part of it is leaning away. This means that different parts of our planet's surface gets different amounts of sunlight and heat. So, why am I telling you all of this? Well, as the Earth travels around the sun, it creates a pattern throughout the year. This pattern happens over and over again, and I'm sure you've noticed it. At certain times of the year, you see the northern hemisphere leans towards the sun, and the southern hemisphere leans away. And at other times, the southern hemisphere leans towards the sun, and the northern hemisphere leans away. That pattern, my friend, is what makes seasons. When the part of the world that you're living in is leaning towards the sun, it's warm and the days are long. Summer. When you're on the part that's leaning away from the sun, it's cold and the days are short. winter. In between, it's spring or autumn. If the Earth weren't tilted, we would have the same season all year long. So, revolution, rotation, orbit. Is your head spinning? Let's do a demonstration to shed a little light on these concepts. Okay, you're gonna need a globe and a table lamp without a shade, plus a table to put them both on. Put the lamp in the center of the table and turn it on. Put the globe on one side of the table. Now hit the lights. The globe is Earth. Makes sense, right? The lamp at the center of the table is the sun at the center of the solar system. Now slowly spin the globe. As the Earth rotates, the sun lights up one side of the planet better than the other. It's day where the light is shining more brightly on the globe and night where it's not. Now let's see what the Earth's revolution around the sun looks like. Give the globe a few spins with one hand while slowly pushing the globe in a circle around the sun, or the lamp with your other hand. So, do you notice how the Earth keeps rotating as it revolves around the sun? If this were the real sun and Earth, by the time you get back to where you started, the globe would have completed 365 rotations or days. And that's another year gone by. So, what does all this show us? It shows that what looks to us to be the motion of the sun in the sky is really caused by the motion of the Earth. So now you know, when you look up and see the sun setting or rising, it's not going around us. It's sitting pretty much at the center of the solar system, while we and the 7 other planets go around it. That sun, always gotta be the center of attention.
Alright, yeah, so a little bit of where the sun goes. Like I said, a little bit basic for some of you guys. I think it's on to lunar movement over here. So let's just go back to the classwork that I had. Go over it for a second. So we have this little diagram here. You have questions. What Earth movement is shown by the arrow labeled A? A right up here. Arrow is rotating, right, around the globe. Then you got B, So you got these questions, and if you go back to the video, if you buffer it, I go over here, we got the rotating thing. We have, it doesn't talk about, it does, the axis right here. What is the name for Earth's movement in its orbit? We covered that. Line labeled C, we covered that, right? This one's a little confusing, so let's just pretend that we're looking at the United States right there. You can tell how if it were to complete its orbit or its rotation, rotation, it would be pointing toward the sun, and what time of year is it when the United States is pointing toward the sun? There's your little clue for that one. And I'll, grade these in a very comfortable way. I wouldn't worry too much. What season is the United States when Earth is at point E? So again, it's not pointed towards the sun. It's not necessarily pointed away from the sun. It's kind of in the middle. So it's one of those two things. You got a 50% chance. At what point in this diagram will Earth be closest to the sun? Got to be in the middle of this elliptical, right? When Earth is at point F, does the northern hemisphere receive direct or slanted rays from the sun? So point F, northern hemisphere up here, pretty obvious. So like I said, I did assign this. This is my first time I'm actually using Miss Morton's Google Classroom. So, let me know, those of you who, attempt this, let me know if it's, something that you're able to do. If I need to rework it, I will. Rework it as in reassign in a different way. So that'll be it, at least for now. I'll be uploading this on my YouTube. I assume if you're watching this, you're already on my YouTube. So anyway, that's going to be it for now. I will talk to you guys in the next one.